In the Call of Duty series, players found a movement glitch commonly referred to as bouncing. When jumping in a certain spot, the game would throw your character far up in the air, letting you bounce off of certain props or surfaces. This glitch was present in Call of Duty 4, then patched in Modern Warfare 2. Its main usage is to access out of bounds or hard to reach area on the map, or for trick shotters to make the shot look cooler. But why? What could happen in the game code that would do such a thing? Well, I was asked the very same question by a friend, and because I am partially on the spectrum, instead of giving a very vague answer about game engine and player controllers and video game physics, I went down an extremely deep rabbit hole about Call of Duty reverse engineering, and in the next 4 minutes I will impart onto you the knowledge required to understand why this glitch in a video game from 2009 is happening, so that you too can hit sick bounces like this one. So, before we talk about the glitch itself, quick primer on video game engine basics. Every object in the world exists on what's called a plane, that is either 2D or 3D, depending on your game, and every object has a set of coordinates that indicate where it is in the world. By changing these coordinates, you can change where an object is in the world. Movement in the world is represented by something called a vector. A vector is simply a way to represent movement on a plane. In this example 2D plane, if I wanted to move point A to point B, I would apply a vector of 2, 3. Moving 2 units on the x-axis and 3 units on the y-axis. For video games in 3D, our vector becomes 3-dimensional, but the principle remains the same. So for example, if I wanted to move this character to this point, I would need to apply a vector that moves its x, y, and z coordinates to this one. To summarize, a vector is how we tell the game to move stuff around the world. It describes by how much you need to change your coordinates to go in a certain direction. Character controller refers to the code or class that control the movement of a character, usually the player. The main difference between controller is whether or not it's a physics-based controller. Basically, in most game engines, there are only 2 ways to make a character go in a certain direction. You can either move the character alongside a specific axis by a certain amount. For example, when a player presses W, I could make it so that you move exactly 1 unit forward. That means the movement is independent from the world and the character forces itself in a specific direction. Or you can make it physics-based. When a player presses W, I apply a vector of force in that direction. This means that the player might not always travel exactly 1 unit forward, as external factor can apply to that vector and either make it more than 1 unit or less than 1 unit. For CoD, we are dealing with a mostly physics-based controller. The player has a velocity vector that describes how they're moving, and it can be modified by the environment around them. To apply forces to an object in the world, we need to use what's called a velocity vector. Put simply, velocity describes our overall movement in the world. It tells us where we are going. This example, when I'm moving to the left, my velocity on the x-axis is negative, and if I move to the right, it becomes positive. Vectors aren't just useful for describing a movement. We can also use them for different purposes, like the angle of impact between 2 surfaces. I'm not gonna go over the specific mathematics behind it, but you just need to know that with just 2 vectors, we can derive a large number of information about what's going on in our video game world. So now you're caught up on the basic, now let's dive into why this glitch happens. The engine Modern Warfare 1 and 2 run on is called the IW engine. It's based on ID Tech 3, more commonly known as the Quake 3 engine. In CoD, a bounce happens when the player jumps from a high position and then hits a surface at a specific angle, causing them to bounce off the surface as if it were a trampoline. If you've played Quake, you might have known about a glitch called overbouncing, where basically, depending on the height of where a player jumps, just as they're about to hit the ground, they are shot up from the same height they've fallen. It's not the same, but it's similar in essence, as the glitch happens right before hitting a surface. Inside the player controller in these games, player movement function are prefixed PM. There's quite a lot of them, but to understand bouncing, we only need to worry about 2. PM_step slide move and PM_project velocity. Step slide move has a very specific purpose. Imagine that your character is actually a huge fridge. Now let's put you in front of some stairs. The stairs are a little bit higher than the plane you're resting on. Therefore, if I try to apply velocity in the direction of the stairs, you will simply be blocked. That's because the small steps that makes up the stairs are slightly elevated, and that if you were to phase through as if you had no collision, you just fall outside the map. To make our life easier, usually developers will represent the hitbox of the stairs as something close to a ramp or a slope, making it easier to walk with in code. So we will consider that for all intent and purposes, a flight of stairs is just a ramp. This is where step, slide, and move come into play. This function checks by how much you are being stopped against the surface, and if the surface is lower than a predetermined value called step height, it will automatically elevate you enough so that you can smoothly pass over, so going a flight of stairs is as smooth as holding W instead of having to jump between every step. This function is needed for stairs and little elevation on the ground so that the player doesn't get stopped by anything that's 1 unit higher than the plane he is walking on. To do so, it will trace a perpendicular vector to the surface you're colliding with, also known as a normal vector, and then it will try to project your velocity on the sloped surface, using the aforementioned PM_project velocity function. And that normal vector is just calculated to determine what direction. Project velocity takes your velocity on the x and y axis, that is, your velocity moving forward and back, and your velocity moving left and right, and then project it on the z axis, the up and down axis. So what it does can be summarized as translating a lateral movement into an upward or downward one. It's needed because we want to either go up or down the stairs, and the only way to do so is to move on the z-axis. So we need to take the movement we have and check how it's affecting our velocity on the z-axis. Because when you're moving on a flat ground, you're only moving horizontally, so if you encounter something that's a little bit higher than you, you'd get stuck. So we need this function to determine how our horizontal movement can help us go up or down. So let's run a bounce in slow motion and see what's happening. As the player approaches the car, they have a lot of downward velocity from the fall, but they're also moving on the other two axes. As the player gets closer to the surface, the game starts to run various checks and notice that the player is close enough to a sloped surface that it should run PM_step slide move. We're only going to look at some part of the function, namely this one. First, we check if there was a collision in this step by checking if the trace was clipped. This is run to ensure that if we stepped up on the last frame, we can now step back down to the ground as to not hover above the ground. It's done to prevent overstepping, like being put higher than where you should be once you return to a flat ground. The part that we care about is the else clause. A collision has happened, the player has just hit the jeep. Inside this, we check if the surface we just hit is walkable, and then we check the vertical component of the surface normal. Meaning, we check if the surface is too steep to step up on. If any of these are true, our velocity is reset to where it was before, and here is where the magic happened. If the slope we tried to hit is both walkable and not steep enough to stop us, we project our velocity using the normal. But remember what I said earlier? The entire point of project velocity is to take our current velocity and then project it into a certain direction. But if the resulting projection is pointing up, meaning the game thinks given our current horizontal velocity and the angle of the slope we should be going up, it will take a movement and translate it into an upward direction, thus giving the bounce effect. Looking at the code for project velocity, this is all happening here, where we compute normalized. The idea behind this variable is that we are seeking the direction of where we want to go. To do so, we multiply our velocity on y and x by the normal vector of the impact point, thus giving the angle at which we hit the surface. Then, we divide that angle by the z component of the impact point, meaning we are checking for a movement that is parallel to the slope we just hit. But if the slope is very steep, but not steep enough to be stopped by the earlier checks, like 0.31, the denominator becomes very small, and if the operation inside this part becomes negative, meaning our velocity is pointing away from the normal, it will become positive, and dividing a positive number by 0. something will lead to a huge positive number. It's a bit finicky since this glitch relies on a very specific set of values to happen, but eventually players are able to find spots where they can reliably hit the angle with the appropriate values. Certain models like the Jeep in derail are also more prone to have bounceable slopes due to the shapes. Bouncing is a pretty funny movement glitch that's caused by the nature of physics-based controllers. A ton of weird movement tech you've seen in-game was born of similar quirks I've just described to you. Things like surfing or bunny hopping I found are very interesting to explain why they happen. Bouncing was patched in Modern Warfare 2, but it was reintroduced by a modder by the name of Xor4D. The devs fixed bouncing by adding a check and step slide move to see if the player was jumping or more appropriately in the air before deciding to project the velocity. By nullifying this check, you can reintroduce bouncing in your game. If you play using the IW4X client, which if you're going to play, I strongly advise you should, you'll need to turn bouncing on by using the bg_bounces command. Additionally, you can use bg_bounces all angles command to make the angle required to hit the bounce more lenient. That's it for this video. I hope you enjoyed this little trip in the world of math and video game physics. Whether or not you are playing this game actively, if you hit a bounce while playing CoD, now you will know exactly why. Peace.